So I welcome Sid Joshi from Oracle. He's going to talk about application development paradigm shift, moving from this traditional monolith that we probably all have been working with to the more service-oriented, lightweight, cloud-native style development. So, Sid, the stage is yours.
Thank you. Hi, guys. Good morning. And it's a pleasure to be here to talk to you about our today's session. Let me introduce myself. I'm Sid Joshi. I'm an EMEA BDM Director for Application Development at Oracle. And I've got a 13 plus 6, around 16 years of industry experience around application development and delivering complex projects at various customers in EMEA. Today's sessions that I'd like to focus for you today is the right application development paradigm. We know that the industry has a lot of traditional applications or monolithic applications we might talk about, and there is a new kid on the block, but not so new kid anymore, which is the cloud native approach or microservices and serverless capabilities that we talk about with various customers. So how do you navigate between these two paradigm shifts? When do you consider monolith or traditional applications still relevant in this modern day and age? Or is it all about cloud native? And how do you tackle those things? And does it make sense to have some kind of a new approach in between all of those? And that's the idea of today's session, and maybe have some kind of discussions at the end towards it. So before I cover anything further, let me just quickly highlight some safe harbor statement from Oracle around some of the technologies I might be talking about might be on the roadmap. So if you're thinking of doing any buying decisions, do not do that. And I'll be very careful when I explain to you about any of the products which might be highlighted here. So the evolution of application development. We all know that in 1980s and 1990s, there has been the traditional way of doing application development with a waterfall model, building a big, huge monolithic application with every encompassing solutions in one place, typically deploying on a physical server on a customer's own data center. That then changed in the 2000s, where the agile application development approach came into the play, where you started dividing the application in multiple tiers, in N-tier architecture, probably deploying your applications on top of a virtual machine like a hypervisor or a VMware or something like that, and running on a hosted environment, maybe in your own data center or a third-party data center. And now comes the 2010s and the latest technologies, where the whole paradigm shift is around building applications using DevOps methodology or GitOps or SecOps methodology nowadays, building a lot of functionality and delivering capabilities with microservices, building it on top of containers, and thinking about deploying in a cloud rather than looking at on-prem. And this is how the application development paradigm has been evolving across various places. Now, let's talk about what do we mean when we talk about monoliths or traditional application architecture. It's a typical application built as a single coherent unit. It has all the functions that needs to be managed and served from a single place. It has client-side services, it has server-side capabilities, as well as business logic and interacting with the database. In the first iteration, as we talked about, everything was encompassed as a single application tier, which you can have the UI layer, the business layer, and the data interface layer, which typically the J2E application stack used to surface or serve very, very well. Then came N-tier architecture, where you are splitting up your user interface to a separate services like a web server, delivering lightweight cache images of your applications and so on. Your business tier, handling your core business logic, interacting with the data interface layer to the databases to interact with some coherent data sets that you might be having for your application. Then later on in the years, we talked about SOA as a traditional architecture of even piecemealing the functionalities of your business tier and your application tier even into finer grained solutions, but it was still a bit chunkier compared to what we have nowadays. But we will touch on that in a second. Let's talk about the characteristics of your traditional applications or monolithic applications. You used to have a very tight coupling between your UI tier, your business tier, and your data tier. You had typically very, very steady workload. As an example, you always knew the kind of utilizations of the servers could be in a periodic time, or you know that in a particular time of a month, you only need 10 CPUs or 20 CPUs of the workload capacity. It wasn't a certain spike of capacity requirement from a 1 second to another, or from 1 minute to another, to be a crazy volumetrics. So you had a very predictable workload, if I may say so. And often these kind of applications were very stateful, or they were very transactional. So you had to have transactional integrity, or you had to know the state of your interaction between your customers or your clients with the application tier. The applications were very long-lived. They didn't change very often. You didn't have a new updates to your application every hour or every day. Typically, they used to be in the back old days, it used to be every quarter. Then because companies start to improve it, and enterprises start to improve it and try to deliver monthly releases. And some have been even been able to do bi-weekly releases in a way of changing the workload. But it's still a very long-lived application that you would have deployed on that. You have a very infrequent update, as I was mentioning earlier, where you have to make sure that all the parts of your applications are in a stable state, is well tested, well proven before you take it into production. You're not taking it very, very quickly in a dynamic scaling perspective. Then from a scaling perspective, when you try to scale your application, you scale your application as a whole. You're not scaling individual parts of your applications. As an example, if I have an e-commerce application and I have a shopping cart service, I cannot just scale the shopping cart part of the business as I need to, but I would have to scale the whole underlying infrastructure, all the application server or the application tier where my applications are running. But that application servers on top of which my application is running provide a wide variety of functionalities, such as managing the security aspects, managing garbage collections, or managing interacting with the database or messaging services. It was a higher tier approach of interacting with my application stack. And the underlying application servers also used to provide you with the capabilities around transactional management, transactional integrity, and how do you scale your messaging or data sources, databases in an effective and a right manner. And let's not even talk about the performance scaling that you would get from a typical application architecture that used to be there. But it's not all rosy and not all bad. So let me now talk to you about the advantages and disadvantages of those typical architecture. In advantages, it was highly densely packed application stack. You used to be able to get high amount of performance throughput for a particular application stack if you tune it correctly. The application is less chatty because everything is sitting on the same virtual machine or virtual servers. So you are able to do in-memory optimizations with that. You get a transactional consistency of your applications when they're dealing with your databases or messaging services and so on and so forth. It used to be, depends on the architecture you went on, a bit easier to debug your problems because you know exactly where the log file is or where the problem is happening inside your application stack. It makes you can think about it, the application deployment as simple because you are deploying it as a whole stack, or complex because you have to build everything together into a single applications to deploy it. So it could be thought about in two ways. But you had to lower up operational overhead because you had to deploy just one application, look after just one environment stack, maybe highly distributed as well. But it was easier to manage with a single pane of glass toolings that are out there to manage such applications. And you had less worries around the cross-cutting corners, such as looking after the security, how do you do the logging, how do you do caching of your application stack, how do you do the memory management. All of that was quite simplified from the application server perspective, being in a single place. And it was a bit easier to implement from a standing start perspective. But it's ideal for a small to medium-sized company or small to medium-sized organizations because you're not trying to build a very complex solution with a lot of moving parts. That's where the traditional application approach was very sweet spotted at. The disadvantages of that is you have a very, very tight coupling of your applications and the functionalities. You have less flexibility around how you change the kind of application development model or the application languages that you're using in that. As I mentioned earlier, you have a scaling confine. You cannot just scale a part of your application. You have to scale the whole application in its entirety to be able to get more capacity or more capability. The update cycle, because it's a whole package application that you were deploying, it becomes a bit slower because you have to test it all and you have to prove it all, and you have to wait for other teams, if you split the workload between different teams, to be able to deploy any new release of your applications to production. That was quite time consuming. Also, difficult to change the implementation of choice to say, today I found a new way of doing certain part of my application in Ruby. It is a much quicker and agile way of doing things. I couldn't just wake up one day and say, actually, I don't want to implement in Java. I want to do it in Ruby or JavaScript. You had to stick to the implementation choices that you made in the past. And the performance impact of one functionality, if one part of your application has suffer, it might have a knock-on effect on the other parts of your applications running in the same application server application stack. And it's harder to distribute the development across various different teams. If you have a very large complex project, it became a bit difficult. And the environment consistency was always being a challenge to make sure that your dev environment is in a similar state to your test, to your UATs, to your prod. That consistency is still trying to really hard to work on. Given the discipline, you might get it right, but typically for most of the customers and guys out there, it has been difficult. Let's talk about the microservices or serverless kind of architecture, as in what is it and why is such a buzz around in the industry for it. In microservices world, you are breaking down your business logic into a very small, lightweight capability, which is only fulfilling a single purpose or a self-sufficient service. It's a small, discrete capability, all-encompassing solution for that particular functionality to work on itself. It externalizes all the states and usually packaged as a container, offloading all the management and everything else to somebody else to deal with. So for a developer perspective, this is the ideal way of doing things, because you are just building your discrete functionality all in your isolation. You're adding all the capabilities that you need for that particular functionality to work. And it doesn't matter if it's running or if it fails, it's idempotency around it. So that's the typical reason or the characteristics of a microservices and a serverless architecture. Let's actually talk about the characteristics now. Your services are idempotent. It doesn't matter whether you just call me right now or call me 10 seconds later. I will give you the same kind of functionality back and same kind of responses back. So it's a very loosely coupled solution because you are loosely connecting to various other services to be able to deliver one solution to the end user. It's typically an ideal for an unpredictable workload. As an example, if I have a service where a customer is trying to order, like an ordering service, I might be getting one request a second or two requests a second, and all of a sudden my requirement goes up to 100 requests a second, and I am able to dynamically scale for such kind of workload without impacting any other services in that ecosystem. Often the services are stateless and very short-lived, and they are easily susceptible for a quick update. I have come across customers who do an hourly update to the services to have a new and innovation functionality delivered to the business at the end of every hour, every minute kind of thing. And they are scaling simplified because they can scale as fast as they can, as long as the container engine has got enough capacity in it. That's a rigidity that's still there in the ecosystem. But I think Kubernetes and other container engine areas are working on auto scaling those node pools as well to take away that scaling confines. And as it's a very discrete functionality, your solutions are very built up. You're building up lots of different services as you go along. Now let's talk about advantage and disadvantages. I do see a lot of advantage, but I've highlighted some disadvantages which you need to be aware of. So let me first talk about the advantages. The decoupling of your solution is the best thing that allows you to develop new solutions, innovative solutions in a quicker time frame, in a faster way, and giving you the high agility that most businesses nowadays need. They allow you to do a quicker turnaround to any bug fixes that you want to do, any new innovative solutions that you want to do, or you want to change your services appropriately. You can do that in a very effective manner. You can scale and have a highly reliable solution. Because it's idempotent, it doesn't matter if one of your 50 pods or 50 microservices go down, it's still, most of the application is still running independently quite successfully. And you're enabling the ability to do continuously build and deliver of your solution from a microservices perspective, and delivering at scale and at pace. So you can have new services delivered every hour, every minute, or even every day. The challenges that I see from a microservices approach is that you have to design this distributed application in a much more thoughtful fashion to say, what is your finest grain of your microservices? How are they going to work together? Somebody needs to choreograph or orchestrate the different kind of microservices that you will be building, and how they will be interdependent on each other. And this requires a bit more time and a bit more thoughtfulness to be able to build properly. Then how do you handle partial failures around transactional integrity solution? So if your application or if your functionality needs transactional integrity, you need to really think about how you implement it as part of your microservices world. Now, because the developer is always concerned about how I'm building my functionality in a quick and effective manner to release the services out in an easy way, they do not worry, or they do not think at the forefront of their mind to say, how am I going to secure my services? How am I going to do logging and caching services? It's an afterthought. It is a thought by somebody else to look after in the enterprises, which needs to be looked at as well, to embed that as a policy or governance around, to make sure that whenever you build the microservices, you think about how you protect those services, how do you do the logging and caching around those application stack. Now, it isn't easy to deploy microservice on its own, but it's a complex deployment approach if you think about all the services that needs to connect to each other and discover each other and relate to each other, which is why we have toolings like Service Mesh and so on. But it's something that needs to be completely aware of and mindful of. This really requires a mind shift. When you move from a traditional way to a cloud native way or a microservices way, you need to change the way you think around applications and around designing and deployment. But if you're born into cloud native world, it's easy. This is all you know, and this is how you've been doing it since day one. So it's okay. From end-to-end testing for microservices, it's great to do a unit testing, or that core functionality of that application you're testing. It's quite easy. But when you have to test the wide varieties of services which are gelling together to give you a single unit of functionality, that becomes a bit of challenging to think about and to execute. You might or might not have higher operational overhead because depend on how well governed and well organized the team is. But you have to keep in mind that there could be higher operational overhead because you need to understand net new solutions for managing, monitoring, securing your microservices architecture, as well as protecting those side of things. Most of the services you might use as open source. So you need to also keep on top of to say, what are the key vulnerabilities and how do I patch them? How do I keep my solutions up to date? And that could be a challenge from that perspective. Your solution could be much more chattier. So because each microservice is distinct functionality for each of the application stack, it might have to interact with other microservices to fulfill an end requirement for an end user or end client, which might make it even more chattier. It could be time consumed to monitor and troubleshoot your cloud native solution, because having to understand which part of the microservices architecture of your solution covers that kind of issue. There are tools out there which helps simplify this monitoring and troubleshooting of the services, but it is a steep learning curve if you're coming new to it, and it is a change of mind set changing to keep on top of that kind of changes. Okay. Let's now talk about the differentiation in a table perspective from application development perspective. So we talked about the traditional approach and a microservices architecture over here. Coupling, you have a very tight coupling, very tight gelling from a traditional applications to the microservice, which is very loose and easy. Code complexity could be very high in a traditional architecture because you're doing the UI layer, the business logic layer, the data interaction layer, all together as one big complex application. Whereas in the microservices world, it could be medium because you're just looking after one piece of functionality. Development time is definitely high for a developer when they're looking at a more traditional application that they're building and deploying, because you have to worry about the whole application as a whole. Whereas the microservices is very low. You are able to build new services, new functionality, and deploy it in a matter of hours or minutes, if you even think about that. The release cycle is typically slow in the traditional way of deploying, whereas in microservices world, it's really, really quick. Development teams are involved in development process simultaneously. You can split the workload to say somebody does the UI layer, somebody does the business logic layer, and then in the end, you try to bring it together as a single app deployment. Whereas different teams can work on different parts of the microservices or different microservices at the same time in parallel, which makes it much more easier to build large complex projects with microservices. Data consistency, I still believe that traditional architecture gives you a higher control of data consistency compared to the eventual consistency in your microservices world. Language adoption, once you've chosen a language or approach of your traditional application stack, it's much more difficult to change. Whereas in a microservices world, you can mix and match whichever languages you want to do to build your functionality at ease. Deploying is a complex one in traditional because you have to deploy the whole application as a whole, whereas in the microservices, you just deploy your services and then look at how do you connect back all together. Updates are difficult to do in the traditional way because you have to wait on the dependency and prove everything is working without making sure any of the other services are broken. Whereas it's a fast to do updates and changes and adopt new functionality in the microservices world. The testing of the end-to-end solution is a bit easier because you know the whole package and you know all the endpoints and how everything is supposed to work in a traditional application way, whereas it's a bit more difficult in the microservices architecture world. Now let's talk about the environment perspective, right? So if you talk about cost per transactions, I believe because the traditional application is really densely packed and it's very resilient architecture and you are sharing the cores, you can probably get higher transactions per cost that you're paying for your CPUs compared to low to medium in a microservices architecture, depending how chatty your solution is become. Workload that you typically have for traditional is a very steady and predictable way, whereas in a microservice is completely dynamic. Process ownership. Now, who owns the solution is very dedicated, but whereas in a microservices architecture is a very shared approach. You have the developers building the services, you have infrastructure operators looking at the infrastructure and the scaling, and security guys looking at the security and the manageability. So it's a very semi-shared responsibility. And you're obviously offloading some of the shares onto the Kubernetes or container orchestrator engine as well. So not everything is done by the developers there. Maintenance, you have a finite set of skills required in the traditional way of doing things, whereas in the microservices world, you have to learn a lot of new package, new tooling, new products and capabilities, which is kind of an uphill battle. But once you know all of that, the life becomes quite easy. Reliability is one system can impact wider place, whereas in the microservices world, it's like a herd, right? If one of the cattle goes down, you're not having any issues. You can still serve the same functionality. Scalability, it used to be a very big problem in a traditional application stack to scale your solutions from one compute or one server to another. Nowadays, with the approach of cloud, this has become a much more dynamic and easier to have, scaling your applications with increasing the capacity from a compute perspective or having extra node for resiliency perspective. But it's only if you're going towards cloud or if you have embedded in on-prem, which might take now minutes rather than the seconds that will take for you to scale in microservices world. Application security. If you think about it from a perspective, if you're going with traditional applications and traditional application servers, you get the patches available in a quarterly or monthly basis for any security related stuff or anything else. So you can easily patch your solutions quicker from a traditional application perspective. Whereas because you have a greater surface area and a lot of different open source technologies pulled into microservices architecture, you have to be really on top of it to make sure the application security is designed to the nth degree. Another thing you can think about is in traditional application side, you have out of the box capabilities provided for providing single sign-on and providing authentication authorizations, whereas the developer has to bake that into their solution as well. So that is something that needs to be very carefully thought about. Now, software security, I think that's where I was alluding to about the patches being available from the vendors where you use the application service from. Whereas if you're trying to do it all by yourself with open source technologies, you have to have a very strict discipline to be on top of every single CVE that is being identified, and you apply patches to your solution. But the good thing in the microservices container is once you've identified it, you can deliver those changes in a matter of minutes. Whereas in the traditional way, you have to test it, you have to prove it, and then it's being delivered. So there is a balancing act in both sides. Capacity is typically customers have always oversized their environments for the peak capacity and not always using it, but you can do complete dynamic capacity scaling for the microservices architecture. So that's the good play. Now, the enterprise world is changing, right? We are moving from containers to DevOps, microservices, and polyglot languages. Choose whatever languages you want to use for developing your applications. A typical architecture is you have a container orchestration engine where you have multiple microservices running with whichever languages you choose, like Halidon for Java microservices, Node.js or Ruby, running on top of polyglot virtual machine like Graal VM. You might have an ingress controller to protect interacting with your microservices. You might have a polyglot database or a file store for storing those services. You might have a service mesh to discover the services. And you might be using the cloud native monitoring and management tool, messaging, serverless, and API capabilities to enrich the solution that you're building from a cloud native world. But how do you combine this microservices and cloud native architecture with the traditional Java application that you have in your enterprises, which is considered as monoliths, right? How do you adapt to this new operational model, and how do you migrate or upgrade at your own pace? And that's where I think a unique solution comes into the play. You could run your traditional apps either on-prem or on a cloud solution where you can get the benefit of dynamic scaling and infrastructure as a code and those kind of things, interacting with the database. But you could also deploy your traditional application as part of a containerized solution in Kubernetes. And that could sit side by side with your microservices. You might actually even build some functionality of a traditional application as a microservices solution. So like an ordering service in my e-commerce application, I think I need that to dynamically scale when there's a peak load and I don't want to scale completely all of my traditional application. I can just take that service and put it as a microservices side by side with a traditional application. When I do that, I can get the benefits of the cloud native architecture, what it brings to the table, but also leverage the modern paradigms around microservices. And then obviously I can enrich those solutions with whatever I need to take out from a traditional application into that microservices world. That is the kind of a hybrid architecture I would propose over here. Obviously, you would use some kind of in-memory data grid to cache or share the data between your microservices and your traditional applications if you needed it, fronting your multimodal databases like a polyglot database. And obviously, then you can enrich and enhance this solution with either serverless capability or asynchronous messaging, and using the same monitoring and management tool like Prometheus, Grafana, Elasticstack, and so on, right? So this is the kind of hybrid architecture you should keep in mind when you're looking at modernizing your applications on-prem or anywhere else. And let me quickly talk to you about app dev at Oracle, and especially from a traditional and a microservices perspective. Now, from a Java perspective, you had an Oracle Java application server called WebLogic from Oracle, which has been the market leading J2E application server for quite some time. And it's at the heart of a lot of Oracle applications, Oracle middleware technologies. A lot of customers and ISVs use that as to run their mission critical system. And it's a very strong brand out there. And it's best known for proving the resiliency, the scalability, highly available architecture, but also the transactionality and getting the best out of your applications and the databases that it needs to interact with, allowing you to have a zero downtime patching and rolling upgrades of a solution completely across from the scale of enterprises perspective. Also elastic scaling and autonomous patching. Now, this product has been evolving at pace. by embracing the cloud native solution, ability to adopt your traditional applications, modernizing it and deploying it as part of a container, as I showed you earlier, building you native tools in the open source format to be able to work seamlessly with the WebLogic operator in a Kubernetes engine perspective, building tools to be able to take a traditional application, build it into a container image, which can easily run in a containerized engine as well, building tools to give you the CI/CD capability to be able to deploy all of your traditional workload in a standard way or even in a cloud native way, and enabling the ability to use modern toolings like Prometheus, Grafana, Elasticsearch, and FluentD or Elasticsearch to monitor and look after the logging for your applications running in a containerized world. Also ready to work seamlessly with your microservices architecture with Helidon as a microservices framework, combining those two functionalities together in a simplified way, or easily integrate with your in-memory data cache with coherence. Building a lightweight, slim images to build your services very, very quickly, and effectively adopting the latest version of Java, running on top of polyglot virtual machine like Graal VM, getting performance efficiency of a quick startup time and a quick service time as well. And obviously providing a long-term support cycle for customers to run it on the longer period. And this same service and solutions are available in the cloud. So if your customer, or if you are looking at WebLogic and you're running it on-prem or any J2E application server, and you want to run that applications in the cloud in a traditional way as a VM way, but they get the benefits of dynamic scaling, infrastructure as a code, standardizations of your environment, and just paying for what you use, you could do that with WebLogic on VM Edition. If you want to go with the cloud native solution and cloud native architecture, where you want to deploy your applications into the cloud in a containerized manner, have all the benefits of the cloud native and all the scaling of the cloud native way, you can do that on WebLogic on Oracle Managed Kubernetes Engine, which gives you all of those benefits straight away out of the box as well. Now, in that case, your potential end state will become WebLogic either running on-prem or on Oracle Cloud as a VM edition, or sitting side by side with WebLogic in Kubernetes, where you're able to get the best out of your WebLogic, your traditional application, you're modernizing it, and you're innovating that solution on the side with your microservices and your lightweight functionality. So you're not having to mothball your existing Java EE solution and building everything from scratch, but you can take piece by piece, chunk by chunk that solution and work in harmony in that ecosystem. Now, from the cloud native perspective, let me just also highlight some open source projects or open source contributions that Oracle's been making in this space. And I will not go into detail, I'm just highlighting some of them with you, and I'll share you the link over here for where you can go and get some details around. So Helidon is a lightweight Java framework for creating microservices. It's based on microprofile. It has two flavors, like a standard edition and microprofile edition. It's even lighter weight than Spring Boot to build your microservices. And with the use of Graal VM, you have a very small images of your application stack, as well as you have a very quick startup time and service time for your services that you might be building. Now, Graal VM is a very exciting technology, and it's been adopted by a lot of customers and a lot of players out there. It allows you to run applications with multiple languages on the same virtual machine. So you can mix and match languages on the same VM. You might have some code of your application running on Java, some bits in JavaScript, some running on Ruby, but they can all be leveraged as part of the single VM, which is quite powerful. Another thing that you get from Graal VM is you're able to have a native image, which converts your application code into a machine native code or standard ones and zeros, enabling you to have a very, very lightning fast startup time. Or even if you wanted to have a condensed image for your application stack, you can also do that. So Graal VM is another open source tooling from Oracle, which allows you to do a lot of cool things. From in-memory data grid perspective, I think, or in-memory caching perspective, Coherence was a market leader in and is still a market leader in this space. We started this area around 10 years ago, but we created a community edition quite recently and made a part of the solution as an open source, so anybody can adopt plain memory caching and data grid option, and use that for the various solutions that they might be looking out for. Now, the most exciting thing from my perspective, coming from Oracle in open source, is this product called Verrazano. It's an open source project where will allow you to do management of combining your various applications in a cloud native way. In other words, it's an Oracle's curated way of bringing all the open source technologies, such as Prometheus, Grafana, Elasticstack, Elasticsearch, Jaeger, Keycloak, and so on, putting it as a single solution to manage, maintain, look after the lifecycle of your applications that could be deployed on any container engine, any Kubernetes cluster, may that be running on-prem, may that be running on third-party cloud, may that be running in Oracle Cloud, but giving you a single pane of glass from an application management and operations perspective, allowing you to do the day 2 operations as well as day 1 operation of your application stack, just defining your what part of your application is using which capability and which functionality, where they need to be deployed, and enabling you to deploy and operate that in a very secure and operational mode. Okay, so those are the key technologies coming from Oracle in the space of cloud native and open source. Now it's time for a demo, but I'm also curious whether there's time for Q&A. How are we doing for time, guys? Is it a good time for demo or?
Yeah, I think you can run a demo for, let's say, five minutes, then we'll have some Q&A until 1.
Okay, fine. So the demo I was going to show you was running WebLogic, which is a J2E application server solution inside Kubernetes engine. In our case, it's a Oracle managed Kubernetes engine, OKE. Where you deploy, when you deploy the solution from a marketplace, the whole stack is deployed in a matter of 15 to 20 minutes. Yeah, it creates you a public and private load balancers, creates you an admin host, it creates you a complete CI/CD pipeline and tooling for managing your application, patching your images, deploying your applications, and so on, creating an operator for you to engage or interact with your WebLogic from within the Kubernetes itself, understanding the idioms and the state that it needs to be in a cluster. And obviously having a Jenkins ingress and egress rules, and absolutely deployed in a secured architecture and a secured provisioning. So we create the right subnets, we create the right policies and so on, and having a shared file store for everything else. So this is a typical architecture of the way you would deploy your J2E application server on a Kubernetes cluster. Okay, that's the kind of a demo. So let me go to the demo site now. So when you go to the Oracle Cloud, that's the way you would see the cloud will look like. Let me just quickly go to the marketplace image. It's always the first time. That's because I was logged out. That session not running for too long. Okay. So you have both options. You have WebLogic as a standard VM edition, but you also have a WebLogic on Kubernetes edition. It's okay, whether you can bring your own license or you can do UC, like pay for what you use on the licensing perspective, which is quite powerful. So we could choose that. We can choose the compartment where I want to deploy it. And underneath the covers is building a Terraform stack for you. So it's easier to provision and then customize the stack as you need to do. Actually, I'm not going to fill everything in. I'm just going to show you what is needed to be able to deploy, and then I'll show you what gets deployed very quickly. So you can choose your private keys. You can choose the number of servers you need as part of the node pool for your J2E application server. You can define your username, your password secrets over here. You can choose the Kubernetes version that you want to use. You want to choose the shape of the node pool that you want to use, complete from a bare metal to a flag shape to a GPU, whatever type you need. The number of node pods that you want. So I would typically go for 2 pod for WebLogic. Then how many nodes do you want in a node pool for your administrative services? Now, this could be also where you can deploy your microservices in your Kubernetes cluster, which is the non-WebLogic one. So you can mix and match your architecture, describing your virtual networks, the subnets for those solutions that you might want to have, choosing which region and which availability domain that you want to deploy your services to, which shape you want to choose for your admin servers and your best in host for connecting to your services, whether you want to choose the existing network or new networks for that, choosing your load balancer shapes, whether it's 100 Mbps, 400 or 800. And in the future, we're going to also have a flex shape. So you can go all the way down from 10 Mbps to 8,000 Mbps as required. Integrate automatically with an identity cloud solution, so you can protect and only make role-based access control to your solution that is being deployed. You can share where the file system is being stored for the sharing the data between the various different applications running on that, and also creating all the relevant policies and networking orchestration, the ingress egress rules, network level policies on the actual compute itself. All of that is done automatically in a matter of 15 minutes for you in the cloud. So I've already got a stack that's running. So I will just go to my resource manager, go to my stacks. So when I go click create, it will create a stack with a job where it's applying all the configuration. It will take around 15 minutes, but at the end of it, you will see the various IP addresses, various endpoints of applications running and deployed. You can also go to an output and see what are the endpoints for your Jenkins server, what is the endpoint for your console, what's the version that's running, and so on. The way you could see and manage your Kubernetes cluster is from here. Developer services, Kubernetes cluster. So this is the Kubernetes WebLogic for Kubernetes cluster I've already created. And in here, I can see the metrics of how the solution is working, how is my node pool behaving. I can interact and update my node pool on its own. But now let me show you one more thing. I am conscious of time, but let me just quickly show you. This is my WebLogic domain, my J2 application server domain already running. I hope it's still logged. No, it's logged me out. Good. I can log in. I can see my domain, my servers that have been configured and running in a running state. Let me just quickly now show you. Oh, this is a Jenkins dashboard. Let me just close this. This is Jenkins dashboard where I have various pipeline to patch my JDK. I can patch my WebLogic domain. I can completely rebase the container images that I'm deploying to that cluster. I can deploy a sample application. I can update my domain with a configuration perspective, a custom application perspective, or anything that I might like. I've already deployed a sample application. So this is how I access my sample application using a public IP address over here. And I could just quickly show you in deployments that sample application is the same one. While that's loading, there you go, sample app is deployed and testing, and it just shows me the URL. So it's an internal URL, but I'm using the same as an external load balancer IP address. So it's routing all the traffic from an external IP to my appropriate backend services. Now let me quickly show you the console. So this is me connected to. So if I describe my pod, WebLogic Managed Server 1 pod, I can see all the information about my cluster, as in what's the configuration and what's the deployment, admin server, how it's being configured, how it's deployed. This is just trying to give you a whirlwind tour of what's the art of the possible and how you can run your J2 application server as the native solution in a containerized world. So let me take a stop over here, and happy to take any questions you might have in this area. So if you want to stop recording as well, you're on mute, my friend.
Yes.